Okay, another problem. I'm looking at this 5.11 is about pressure. Sa 5.11, if you had liquid whose density was half, so we know that the barometer was the barometer that was invented is made of mercury. Actually, dependent lang at density of mercury. That's why the calibration, I mean the units for one of the units in pressure is a millimeter Hg. So I mean that is the millimeters, the height of your mercury with respect to the atmospheric pressure. Now you have already a substance that will be used instead of mercury that will measure pressure. So basically you will go back to your, I think this is in physics, physics about pressure. Your pressure is um, rho Hg. That is raw. May I scramble things? Rho Hg. So this is grams per. I'm just analyzing the units. Grams, and then you have centimeter, let's say, and then you have meters per second squared, or let's say centimeters per second squared. So that would be this is meter, this is meter. So that is meter per second squared, then kilogram meters per second squared. So this is energy, which is no. So for your pressure, that should be your pressure is equal to force all over area. Okay, if that is given, so this is a common formula, of course, from your physics. Your pressure is force over area. To physics. Of course, in high school, di rin man niya sugad ka kore siguro. So, force over area. Now, you have given a 750 millimeters of mercury. This is pressure. So, if you're looking for the height, that would be um, how much? Force is mass times acceleration. Diba? Force is mass and acceleration all over area. Then your density is, if you were given a density that is mass all over volume. Okay? So volume, acceleration, for this to be volume, you should have had another length here. So that is the height. Okay? So this A is equal to the G. So this is dimensional analysis. I'm just looking at so basically that 750 millimeters of mercury, you can deduce it to mass, and then your G, and then your height of mercury all over volume. So this is density. Oh, so that's a rho Hg. Amo na di rho Hg. Kaya di naman nandiyan unit kanina. Bago may sayo. Force is mass of acceleration over area. Mass G, and then H area, and H, that would be V. Then M over V, mass over volume is density. So ano naman talaga? Rho Hg. Okay. So you have a density which is half of the density of mercury. So you would be saying density is one half. So your mercury is 13.6, the density of mercury. So half of that, din ka sa 13.6, constant ito. Ito yung mga constant, mga density. 13.6, so over 2, that is your gram per cubic centimeter. And then you have a 9.8 meters per second squared, and then of course your height. So if I will put this in terms of uh, force all over area, Pascal, ikakadto ko ya Pascal. So I will convert that to Pascal, 750 times um, millimeters of mercury, tapos 760 millimeters of mercury. This is a constant, and then that is 101, 101,325 Pascal. So that is already Pascal. That is Newton per square meter. Oh, sir. Kuro man, sir. Kay, para malaki ni feeling problem. Diretso malaki ni. Okay? So, you have your Newton here. Your Newton is kilogram meters per second squared. Okay? So, that, your height, that would be, of course, you have ang mga igbaw, ang mga ubos-ubos. So, you have 750, cancel na ang unit. Then, you have 1,001,325. It's another constant. This is Pascal. Pascal in terms of ATM and ATM in terms, ano to calculator niyo? 101,325. That is Newton or kilogram meters per second squared. That is your Newton. May over meter squared ka pa. So that is your Newton square meter. And then may the ka times 2. Di man? Ma-times 2 ito nga di. And then you have, mula, haubos, you have 13.6 wala na unit. Then you have 9.8. 9.8 meters per second squared. So, maka-cancel ko ito meters per second squared. Meters per second squared. So, I have unit of kilogram per meter squared. You have unit at 13.6. May unit ito man. That would be gram per square centimeter. So, I'll convert the grams. I have 1,000 grams is 1 kilogram. Cancel. Okay? And then I have 1 meter. 1 cubic meter is equal to 100 cubic centimeter. Of course, canceling this cubic centimeter and may sasalin nga meters. So, the answer must be in meters. Okay? So, that would be it. So, 750 times 101,325 times 2. Ato tiyo Brown, nga kung gini mga reader. So, you have to read those. Ato to read do. Hindi nga mga concept kay Brown na niya kinsusolve. Times 9.8 times 100 cube. And that will give us 1,140. 1,140 meters. Ang taas, di ba? Kailangan mo masyadong mataas pag half ng density ng mercury. So the same is true for mas mabigat kay mercury. So hindi mo kailangan na masyadong mataas para ma-measure yun. Yung problema lang, kasi si mercury yung pinaka-liquid na may ganon kabigat na um, may ganun ka bigat. O, advantage yun kasi after kay mercury, sila mga solid na sila. O, mahirap na sila at room temperature. So, ibig sabihin, kung magagamit mo yung mga metal as like a mercury for a barometric pressure, kailangan mainit sila. So, hindi mo sila magagamit sa barometer kasi atmospheric temperature ka lang. Magsusolidify naman yung mga metal mo. Nakita mo? Bakit mercury yung unang ginamit na barometer? Because of its density. O pag nag-half tayo ng density, mas magaan sa kanya, tingnan mo, masyadong mataas yung kailangan para ma-measure yung yung barometric pressure. Okay, masyadong mataas. So kung tataasan mo naman, walang ganun. Kasi si Mercury yung pinakamabigat. Okay? So, that must be it. Thank you guys for listening.